All right, I'd like to go over expectations for the sort analyzer assignment. I really like this assignment. It's fairly straightforward, but it reminds me of like a science experiment because we're going to collect data on how fast it takes or how long it takes, sorry, for each of the different sort algorithms to sort different types of data. So there's the assignment here, right? We're going to create a program that analyzes the performance of the bubble sort, selection sort, and insertion sort on various types of data. Okay. So actually, why don't I just show you the program? I have some Python starter code that I can share with you. And very straightforward, it's just a bubble sort random data, bubble sort reverse data, bubble sort few unique data, bubble sort nearly sorted data. Selection sort random data, selection sort reverse data. So I just select one. Let's do the selection sort, maybe 5, selection sort random data. And I hit enter, and it gives me the little title. It's doing the sort right now, so it's going to take a certain amount of time. And it took 6.8179776 blah, blah, blah seconds. Okay, cool. And maybe I want to do reverse data, so 6. And it'll take some time, blah, 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 and away we go. So that's basically it, right? We've got these 4 different sets of data that I provide to you so that we have all the same kind of starting data. Random data, reversed, few unique, so they're all the same except for a few values, and nearly sorted data. And actually I thought I had it printed off, but I didn't print out the arrays. But that's all in here, right? So if you wanted to download just the data files so that we all have the same starting data, you can download those data files and load them into arrays, and this is what you should end up with, these 4 arrays. If you do the Python start code, I do the loading the files for you. Once you do that, collect performance data. So you have those menu options and you time it. I'd suggest maybe doing 1 or 2, 3 trials for each one, taking the average time. Might be good. In JavaScript, you can use performance.now to get this current timestamp. In Python, import the time library and go time.time, right? So start time, end time, and then this is where you would do the actual sort, and then it should give you how long it took to do that stuff. And then you can put your results in the table here, right? And this is what reminds me of a science experiment, right? We're gathering data, we're recording it in tables, and then I want you to analyze the results and see what kind of observations you have, right? So you should kind of notice some interesting patterns here, and these questions kind of help guide you to those patterns. All right, so basic criteria: you've created the data arrays from the data files, or I've done it for you in the start code. Okay. Your sort algorithm's performance times are correctly determined and recorded, right? So you've got the proper functions and they're running the algorithms and you're recording them. And good looking code, right? Make sure your code has comments in it, good variable names, spacing, it's organized, efficient, that good stuff. Okay. And then the extended criteria is the explanation of the results. You know, your answers to this, do they show a really rich understanding of what's happening? Right? Do you understand the algorithms? And you can say, oh, it's interesting. I know the algorithm works this way. That's why it's slower in this case or faster in this case, right? So I'm going to look at your answers to those observations there. All right. And then the marking guide. Okay. Hope that makes sense. Have fun. Take care, and we'll see you in the next video.